Since I was a young boy, I've always wondered why cars are so inefficient. They have an extremely inefficient aerodynamic design. If you look at a plane, you can see pressure recovery at the back, a very slow angle as it goes to the back. In a car, you have your back windshield and your trunk and a lot of separation. So I have designed the E-Pod. E-Pod is a two-seater tandem electric vehicle that will be one of the most efficient production vehicles in the world. The E-Pod has less than half the frontal area from your standard automobile. And this is because it's only a two-seater vehicle, and instead of sitting side by side, it's in tandem so that the passenger sits behind the driver. Also, the aerodynamic drag coefficient is going to be about 0.15 to 0.1, which is less than 3 times of the normal automobile. This results in a much lower drag and results in much higher efficiency, especially on the highway at high speeds. So for the E-Pod, my biggest concern was efficiency, eco-friendly design, and it being an electric vehicle. Also, crash test is very important, so I want high crash safety, so I have a crumple zone in the front and the back. So it's a very safe vehicle. It uses almost no energy to run, very low running costs. I also want the vehicle to be very cheap so anybody can afford it. You'll be able to fix it yourself with a fiberglass body or a different type of body where you can cut out a section and fix it yourself, and everything will be very cheap and easy to fix. The E-Pod features a tadpole 3-wheel design, 2 wheels in the front and 1 wheel in the back. This allows the car to be tapered very gradually in the back to a point so that the air can flow perfectly over, which reduces the drag. The blue area of this model is flexible solar panels. So everywhere you see blue, so if you're looking at the car from above, the sun will shine down and charge the solar panels. It'll charge the onboard batteries to power the vehicle. So when you're traveling in town, you should be able to get enough power only from the solar panels. You won't have to plug it in. If you're driving a lot on the highway or you're driving a lot in cloudy days, you can plug this vehicle into your house to charge it. It's also a mobile power unit, so whenever you're traveling with the E-Pod, you have a huge amount of solar energy that you can use. If you're camping, you can power a huge amount of things, fridge, everything off the E-Pod. When you're not driving, there's so much solar energy that's here. When it's parked at your house, if you're not driving, you can use the energy generated by these solar panels to use in your house. So you actually use the onboard batteries and the solar panel as kind of a home solar system. The pod will have front windshield as well as a door, which is for both the passenger and the driver. It will rotate up because of the curve of the vehicle. As well, there's a door here for storage. There's a trunk. It will open in the same way up. The E-Pod will have aerodynamic covers for the wheels. Now if we open the vehicle, we'll see what's inside. So inside, this is a working model. I'm testing the systems on this model. So I have an electric motor which drives down to the rear wheel using a reduction. So on the wheel system, this will be a belt or a chain. And I have lithium-ion batteries. Now the battery on the full-scale vehicle will be these 18650 cells. I'm going to make, for the test vehicle, my own battery pack using used laptop batteries. I bought about 100 laptop batteries for $8, so you can get very cheap used lithium-ion cells. The battery will have maybe 500 cells for 2 hours on the highway. The electric motor will be extremely small and efficient. In the test model, I'm going to be using a golf cart motor, and golf carts usually only reach about 50 or 40 kilometers an hour for the high performance types, but this car will be able to reach 120 to 130 kilometers an hour using only a small golf cart battery because the body is so efficient. This vehicle will have less battery weight than the average vehicle. You can just charge with electricity, which is much cheaper than gasoline, and also the motor is so simple. It's just this small thing, has one rotating part and one coil on the outside. Gasoline engine with its valves and piston and everything else, there's so many problems and so much maintenance. This is virtually maintenance free. You can run it every day for 20 years without any maintenance at all. So this will be much more efficient again than a normal internal combustion engine car. You don't need a transmission for electric motors. They have a great torque band throughout the whole operating range. So you can just use a chain to connect it to the wheel, and you just have a certain ratio of 4:1 or 5:1, and that's it. You just put on the gas and it starts right from startup all the way to highway speeds.